Good evening, everybody. Once again, welcome to the webcast where we cover 500 locations around the country and have about 400 windows open. Hopefully we'll try to get through this. Fortunately, we're going to be drilling down to one particular area, and that's going to be the southwestern U.S. Let's take a look at the warnings and watches we have in that area. Mostly a lot of winter storm advisories. We have this one box up here. Still getting used to the Weather Service scheme. That's a winter weather advisory. Then we have winter storm warnings in the mountains and then high wind advisories in the deserts. So let's take a look at AWIPS. AWIPS, this is the system that the National Weather Service uses in their office, and you're getting a little peek at that here. So we're going to try to use some of this every now and then. It's not the best tool for everything. All the different tools, they have different strengths and weaknesses, and this one is good for radar, like you see here. This is a composite radar showing basically all the echoes around Arizona. And by composite, we're talking about the highest reflectivity observed in the vertical above a given point, such as right here in the desert. You're looking at all scans, all tilts from 0.5 up to 19 degrees, and this is showing the highest reflectivity. It's different from the base reflectivity that you get when you're looking at tornadoes. All right, let me take a look at chat, make sure our audio is good. I was messing around a little bit with the audio board, so I want to make sure there's no problems, no complaints. And tornado warning southwest of Beaumont. Yeah, we've got a little storm cluster that is set up right there, and we might have to look at GR level 3 or GR level 2 for that. There it is. So it's getting a little bit of inflow off the Gulf with this very moist southerly flow. So while we're waiting on that, let me get GR level 2 started. And this is, again, this is composite reflectivity, so you're not going to find a hook on this particular product. But this is good for focusing on where you need to be looking, and it gives you a very quick look at where the strong cells are. So even if they're elevated, you're pretty much on them. So I think we're going to be looking at the Houston radar. This is kind of in between Lake Charles and Houston. Looking at the counties here, maybe a tad close to Lake Charles. I'll just go with that for now. So let me start loading in that data. That'll take just a minute, and we'll look at some of the other charts here. Okay, so there's the watches and warnings. Here's the satellite. This is the infrared satellite showing this next system, as you can see, moving through the Rockies. So it is mostly out of California and shifting into the southwest deserts. And out to the west, you can see this open cell cumulus pattern. This is the unstable air in the trough region behind the frontal system. So it tends to be kind of showery, blustery weather, and windy, and definitely a bit cooler. But you can see some of the stronger showers. The more organized stratiform showers, they're out in this region of Arizona along the Mogollon Rim and in the Tucson area here. 500 millibars shows a little bit of the big picture, what's going on. You can see that very strong Pacific flow coming in. Got about 65 knots there at 500 millibars, and that's going all the way across Tucson and over to Oklahoma and Arkansas right there. And you can see that trough area right here. In fact, this is a large trough right here, and this is where we're seeing some of that instability, that cumuliform cloud there on the infrared imagery. Highs today, they've warmed up quite a bit. We got 80 degrees there, just west of the Galveston area, 78 there at Houston, so temperatures have come up quite a bit. And you can see the front is pretty well to the north. Temperature's a little bit mild out in California, though. So the front is somewhere in between there. Let me see what product we should look at next. Probably a good time to switch back to the Beaumont radar, the Lake Charles radar, and you can see that tornado warning right there. So you can see that this is the base reflectivity, and you can see it has a much different appearance than the composite reflectivity. So this is where we go to find hook echoes and severe weather signatures. And let me get rid of some of these overlays and you can get a better look at the storm. Storm just west of Beaumont right there. We see a few indicators of severe weather. There's a very strong reflectivity gradient right in this area here. Don't really see any hooks here. We see very strong reflectivities, up close to about 65 dBz's right there. And here we can see what looks like a little bit of a notch. So this is where we might look for an updraft. One way you can get some more information is to go up to higher tilts. Let's go up to 0.8. See, we're down at 4,000 feet here. But if we go up higher, well, we've got older frames here, so we see the storm kind of bounce out to the west a little bit. But we can still look at it, and you can see it's got kind of a bow shape here. So possibly a little bit of downburst action associated with this. And yeah, you can see it even more pronounced up here. This is up at 11,000 feet. Here's the rear inflow notch. So that's a very important signature. And fortunately, we're in luck because the wind flow in that notch is parallel to the radar beam. So we can look at storm rail, or no, for wind, we're going to use base velocity. So let's check that out. And what do we see? We see inbounds of 42 knots, 39, 42. Remember, this is up at about 11,000 feet. We want to go a little bit lower to see what it is at the ground. And here we pick up the newer frame, and we've got about 46 here, up at about 5,000 feet. Then we go a little bit lower, and we're getting about the same there. And most of the time I find that the ground winds are slightly below, maybe about 70% of these radar-indicated winds, so we're talking about 30 knots or so. But that can vary quite a bit where you have gusts and spin-ups and microbursts. So there's another look at that, and we can also look at storm relative velocity. Let me set a good vector. We're going to go probably for about 230, maybe 240 at 15. And we get a little bit more of a balanced picture here. And this gives us kind of an indication of a little bit of a meso right in this area. So there's a couplet between here and here. And the diameter, the scale we're talking about, is across about 5 miles. So that's a pretty classic mesocyclone, not particularly strong, 34 in and 26 out. That's about 50 or 60 knots. It's rotating some. Well, I should say it's definitely rotating, but fortunately it doesn't look like anything tornadic at this time. Here the couplet does look a little bit tighter in here. You see that gradient right there. Now that's a little bit more concerning, so let me zoom in on this. We've got 19 in, 20 out. That's about 30 knots of shear right there. So nothing tornadic here. 24 out, 16 in. That's still kind of light, but now you see it picking up a little bit on this next frame. So things are coming together a little bit here, tightening up. This couplet is about 1.5 miles in diameter, and we're seeing about 37 in, 26 out. It is intensifying here, so looks like we're seeing something coming together right here. So it looks like the Weather Service is on top of things, and Let's see what that looks like in the reflectivity. Right there in that notch right there. So if you were out ahead of the storm, you would be underneath this updraft base, kind of a rainy updraft base. You would get kind of wet, probably lightning coming down, very messy, but you'd probably be able to peer into here and get a little bit, see a little bit of the wall cloud. That's probably what's going on right there, right now. And we'll come back to this in a minute and see if we've tightened that up further. We can look at spectrum width to see if there's any trouble there, like the debris clouds will sometimes show up. A little something here, I don't know if that, we would have to look for consistency on that. But anyway, there you go. That's getting towards a rotating wall cloud, possible tornadic circulation right there with that frame. Looks like the notch is kind of grown a little bit. Anyway, we'll come back to that in a minute, and let me just go over the chat and see what's going on. And I'll say hello to, got Sue here, and Kevin and Alexi. Mark's here. Brian says it's finally Friday. And Eddie's here, Sarah Sue, and Jeff. Jeff says local storm reports say 3/4 inch hail in that tornadic cell. All right. We've got a lot of charts lined up here, so let me continue on. You can see on this SPC product here, this is the mesoscale analysis, showing the low-level wind flow. And you can see there's a little bit of a low-pressure area here, and some southeasterly winds. This is what's feeding that cell cluster right here. And we can take a couple of look at the important severe weather parameters. We'll look at the most unstable Cape, and we see values of about 500, not particularly high. That's in the marginal thunderstorm range, but of course the storm relative felicity is what's really important. So surface to 1 kilometer. Now keep in mind that a lot of this has been distorted by the convective activity going on, but in this untapped area, 1 to 200, that's going to be marginal, getting into the low to moderate end of tornadic values right there. Then we'll take a quick look at 3 kilometers, surface through 3 kilometers, and we see it a little bit higher right there. Okay, let's see, what are we going to look at? Yeah, let's take a look at the surface chart. This is what's going on out in the desert southwest. You can see we've got cloudy conditions and kind of a south wind here at Arizona. And out in California, we see westerly winds in here. So the question is, where is the front? There is probably a front in here somewhere. Normally what we do is we go to the INCEP analysis. This chart, we do this almost every night. And let me fix this window here just a second. Okay, you can see the thickness gradient is still pretty far to the south, almost down in Mexico. So offhand, we're kind of looking for a front down here, but we're seeing things acting a little bit strange with the system. Some of the frontal activity is kind of, we can, on some of the other charts, I can pick up that front coming into Arizona and California. So we're not getting much help with this. It's kind of a shallow system here. What I'll do is I'll go to the, yeah, let me show you this real quick. I got to figure out in which of these tabs I had. Yeah, here it is. This is the METAR plots. I was looking through these. Let me show you San Francisco. This is one way you can find fronts. You use continuity at a given station, look at time trends. So if we dial this back to last night, here you can see the day of the month, and then after that you can see the time here, hours and minutes. So 5:56, that's going to be close to midnight. You can see at that time winds were out of the south. South-southeast, 150 at 13, 160 at 11, 140 at 9. Just some light rain, some broken ceilings. And then we can see around dawn, we picked up very strong westerly winds, gusting 33 to 43 knots. That's almost 50 miles an hour. Thunderstorms, squall. Things got really bad there this morning. And then after that thunderstorm area cleared, winds were out of 230. Well, they came back around to the east here. And then around 18Z, pretty solid westerly wind here. So this looks like the frontal passage probably right in here. What does the temperature do? It kind of falls, hangs around 2934, 2935, starts coming up. Looks like it stays about steady here. However, the winds are out of the west there. Let's take a look at Los Angeles. And I don't think we have Ron here. Ron would probably be enjoying this, covering the weather in his neck of the woods. And you can see earlier today, 18Z, winds out of the south, 160 at 11, 150 at 15, 150 at 12. And then right around 19Z, that's going to be early afternoon. Winds come around to 220, 210. That's probably the frontal passage right there. And we can do one more real quick. I think NYL is that Yuma? Yeah, it is. Let's see what Yuma is showing. Looks like on this very last one, they got some weather happening right now. So you can see winds were out of the south, 23 gusting to 29, very gusty out of the south. And then we get this west wind. Now that could be convective, that could be the front coming through. So anyway, it looks like we've had maybe some sort of front moving through this area during the day and just now getting to Yuma. And do we see that on the radar? Well, the radar cache hasn't updated, so don't have anything to look at just yet. I can see it's saying it's creating image, but there it goes. Yeah, this could be the frontal boundary right there. So that's how we can go about finding fronts in very difficult conditions in the desert southwest. And the one other area that I haven't gone over yet is using your jet and your troughs to find the front. So here is your jet stream. It falls in this channel area between high cyclonic and anticyclonic vorticity. So this is a big jet max out to the west. And it goes like that. And then we have this trough right off the California coast. This corresponds to the cold air. Then we have this ridge out in the Four Corners area. So this is telling us maybe we expect to find the front halfway between the ridge and the trough along where the jet is. So this is kind of where we would look for that based on the upper air patterns. And I know this is hard to read, but this is Arizona right here. And it's possible if we fudge this a little bit and bring it further north, that corresponds to the front passing through Yuma. So that's another way you can find the fronts. So let's carry this forward and see what happens with the upper air dynamics as they come into the southern Rockies and the plains. Okay, so Texas is right here, and California is right there. I haven't found a way to change these state borders, so anyway, here comes the trough. This is going to be tonight. Lots of upper level lift coming into the southern Rocky region. And then by tomorrow night, when we do the webcast, we're going to be on this frame right here. Jet stream is going to be running like that. It's going to be in the South Texas area, in the Big Bend area, and in southern Arizona. Very long jet max, kind of like that. And some of you are familiar with the left front quadrant. It's going to be right in this area here. So this is an area of upper level lift. We'll be watching for cyclogenesis in that area. And we're talking for tomorrow's webcast, we should have some more interesting weather to look at. So the main trough is going to move into North Texas that night. And then when we do the webcast on Sunday, now we focus on the southeast U.S. There we go. Very strong trough here. Very strong jet max too. So we're focusing on the area just south of the western Florida coast. If we have enough moisture and instability, we could get some severe weather, probably in a corridor from around New Orleans all the way up to Georgia by evening. And further back in Texas, here comes the ridge. Should start seeing improving conditions here in Texas on Sunday. And then for Monday's webcast, we're looking like this. Big ridge, another trough, another storm system out in California. There it is right there. So more weather on the way. And that's the end of the NAM run right there. So that's what's going on there. Let me take a look at the chat one more time, check in here. It's probably time to take a look at that storm system near Beaumont, see what's going on. And it's got kind of a bow-shaped look right there. Not a prominent one, but, you know, definite bit of bowing there. Still got a tornado warning on that, right around Vidor. And severe thunderstorm watches, severe thunderstorm warnings too. So we're talking about, let's see, what county this would be. Orange County, heading right into Orange County right there. And then just taking a quick look at the higher tilts, we can still see that notching right there. So the area that's most under the gun, let me project this forward, kind of see what's going on here. Yeah, we're talking pretty much in this corridor right here. So the town of Vidor and Morrisville, that's where we're looking for probably high winds and, of course, a risk of a tornado as that comes through. But, of course, the rest of the line, there is some risk with that, especially when we're talking about bookend vortices way up here. So if we develop enough vorticity along the north edge of that, if we get enough bowing, that can spin up some embedded tornadoes in that part of the line right there. So that would probably affect pretty much anywhere in here. And we'll take one quick look at velocities here. It looks like it's let up a little bit here, looking a little bit better. You remember earlier we had things a little bit tighter in here. That looked pretty scary right there. But now we're just looking at more just outflow right there. Okay, it's time to head into the forecast, so let's do that real quick. And we've got a change coming up for next week for sure. Let me get this all set up here. I've been moving all kinds of windows around, and I think we are set. So let me back this up. We're looking at the GFS. So over the next 24 hours, we see that storm system coming into the Rocky Mountain region, as I mentioned earlier. See, there it comes. Pretty good line of precipitation coming into the El Paso area tomorrow. Then for tomorrow's webcast, it is in Texas. However, we're lacking moisture here. So even though we get the left front quadrant of the jet, we do get the pressure falls, but there's not much in the way of precip. But you can see that storm system really deep in right there. So then for the webcast on Sunday, things move into the southeast U.S. as I mentioned. Funnel system looking like that, and we have another Pacific system moving inland. So that'll cross the Rockies, and here comes the front on Tuesday. Then by Tuesday's webcast, that is in the plains. You've got a bit of a snow band developing here in Iowa. And we can see this 540 decameter thickness line sneaking south, and that means a cool down coming as we get this cold air advection coming south. So there goes that, and we got a Great Basin high developing, so a lot of cooling going on in Idaho and Utah middle of next week. And now you can see even more cold air coming south. And then this next frame is interesting here. This is on Monday, the 30th. Got the 510 decameter line coming into Arkansas. Now, I don't know how much air mass modification is involved here or what, but those are some very low thicknesses. If I had nothing else to go on, I would probably be thinking of highs in the single digits to the teens. Teens and 20s for Texas, but we shall see what happens. Okay, so that's the main story right there, and it looks like it brings a 1060 millibar high on down from Alaska. And that's going to mean very cold air for sure if that pans out, but that could just be the GFS cold bias coming in. I don't know. And I haven't had a chance to take a look at the Canadian and European models. I'll just run the Canadian model right here. It goes up through 240. And it only gets us up to the 30th. But it is bringing a chunk of, you can see that 510 decameter coming right down here. So looks like the Canadian model is kind of on board with bringing the cold air south also. So looks like a change there. And I think that's about all I got here. So let's see, 8:30 here. Let me check the chat, see if there's anything else going on. January 31st could bring teens to Florida per GFS. Yeah, that'll be some definite news. Anyway, I appreciate you all watching, and have a good evening. We'll see you tomorrow.